Okay. Now it counts.
Oh!
Oh, come on! Not again! Yeah.
It's button bash time! Now let's build button bash together. Until this point in this course, we've designed primarily single user interactions. This would be pretty much our first build where we bring a second player into the mix. And along with that, we will hopefully utilize a few tools we picked up and covered in the last couple of units. Variables, of course, computed conditions, and scenes, which will act as game states. We'll transition between a pre-game state and an in-game state, moving back and forth. Hopefully this will give us a more polished, game-like feel. So, let's get this party started, shall we? Now, along with the digital master, you would need 2 momentary switches and possibly 2 LEDs. You need, of course, an Ethernet cable and an RJ45 breakout. In my case, I'm utilizing these arcade-style buttons, which have an LED on the inside, which I can make glow, which is absolutely amazing. And I also have, of course, the RJ45 coming out off the bottom of the box. By now, you should be pretty comfortable setting up the digital master and the media master if you're gonna need it. But to show you what I've got, I've already set up my input and output channels. So we have, of course, the green button and the red button and their LED lights. And I've, of course, set up the digital masters to save us a little bit of time. So let's jump into scenes before we look at our behaviors. We're going to create 2 scenes. The first one, the pre-game scene. This is where players signal that they're ready to actually start the game. The in-game scene is where all the action happens. We'll keep track of the button presses, keep track of the scores. We will decide who the winner is and trigger the winner behaviors. And after that, transition back to the pre-game scene. So let's actually start with the second scene, which is the in-game scene. And then we'll work our way back to the pre-game scene towards the end. So to create a new scene, we actually need to click on this button right here. So now that we have our second scene, let's start building in our behaviors. But before we do that, let's actually create some variables. We know that we want to keep track of each team's score. So we can do that through the help of a numerical variable. So let's go in and create red score as well as green score. So now that we've created our 2 numerical variables, we need to then start building in our behaviors. So in the behaviors tab, we can now build our first behavior. So we want to keep track of how many times a player presses a button, which is the whole point of the game, by the way. So we want to use a states match to increment each variable. So let's actually choose the first one, states match. When the green button is pressed, go ahead and update our green score variable and add 1 to it. So that's pretty much it. And we'll do the same for the red press. Now let's move on to the gameplay behavior. This is actually the game round the players actually play. We actually want to use when scene started. To kick things off, we actually want to have a little, maybe a countdown would be great. I've already imported some media files, so I have a countdown here. You can, of course, download these. And then I want to have a little bit of a delay while the countdown is running, maybe of 3 seconds. After which I want to reset the scores. So remember, we have the player scores. We want to make sure that at the beginning of the round, we actually reset them both to 0. So we want to update our variables, both of them to be 0. And then we want to actually maybe do the gameplay audio. Okay? I actually downloaded as well a gameplay audio and set up another delay, which is how long the game round is. I experimented a little bit with 20 seconds. I think that's a little bit too long. Find what works best for you. But for this purpose, I'm gonna use 15 seconds. So after 15 seconds of pure button mashing, we want to determine who the winner is. But here's the thing. COGS doesn't natively allow us to use the greater than logic within a standard states match. To do this, we actually need a computed condition. You might remember these from the last unit. So we need to compute a condition that checks who has more points and therefore declare that person the winner. We have a few ways to actually achieve this. The first and possibly easier way is to do it as a standalone behavior. If you try to add a behavior, you can see computed condition right there. But the issue with setting it up as a standalone behavior is that COGS actually continuously evaluates and checks this condition while the round is ongoing. This is not what we want. We actually want to check it at the end of the gameplay round, which is 15 seconds. You might remember as well, a second way to do this would be through an action, an if then otherwise action. We can actually change from states match to computed condition. This is actually perfect. At the end of the delay, we'll actually check who the winner is and then declare them the winner and execute the associated behaviors. But this is still not perfect. There's an even better way. You might remember as well from a few units ago, we talked about started by action behaviors. These are, in essence, little functions that house certain behaviors. We can call upon them within other behaviors to say, hey, can you do that for me? I don't want to do it. And then we can actually execute the checks and declare the winner through another behavior. This way we can keep our code really clean. So let's see how we can execute this in COGS. So let's go ahead and call our start behavior action, which will call upon a behavior that we are going to create in just a moment. So now let's create the end game behavior. So we actually add a behavior. It's a started by action. Let's call this end game. So in the end game behavior, we want to compute some computed conditions. So we'll choose an if then otherwise action. We want to check for 3 conditions. If the green team has won, if the red team has won, or if it's a tie, in the unlikely event that both teams have the same number of points. And we want to actually check, so if computed value. Now to access a variable, the syntax is scene dot variables dot variable name. I think we have green score dot value to access the value of the green score. So I'm actually going to copy this. So if the green score is greater than the red score, then go ahead and declare the green team the winner. So we'll handle what happens later. So let's check the other condition, the other 2 conditions. So we also nest another if then otherwise action in there and change that to a computed condition. So I will go in and copy all this and paste it right there and just reverse the sign to check the other condition. You can see it says false because both teams have 0 points at the moment. So, and then the last condition would actually be a tie. So now we can go in and program what actually happens in the case that green wins. To do that, we could actually program it in there, but since we now know we can use started by actions, let's actually keep everything clean and use the started by actions. So we'll use started by behavior. We haven't made it, so we'll add it later. and start behavior. So now it's time to set up the green win behavior, red win behavior, and the tie behavior that actually does something in the event that the green team wins or the red team wins or it's a tie. So let's do that next. So let's set up a new behavior. Let's call it green winner. It's also a started by action behavior, green winner. So we can decide what we want to happen in the event that the green player wins. In this case, I'm not using the Media Master, so I don't have to worry about any output on the Media Master. I want to rely on actually the LEDs on the inside of the button. So when a player wins, I want the LED to flash. So if the green player wins, I want the green LED to flash, maybe 10 times. Yeah, let's do that. Let's do that. So this is started by action. You might remember we can use a loop to repeat certain actions, like a flashing LED. So I'll do that pretty quickly. And for this loop, I want it to run a total of 10 times. So I can choose number of times right here. So I want it to run 10 times. And I want to update the green LED to on, delay, and then I want to turn the same LED off, and then wait another 0.2 seconds. If you don't do this, your blink will be a little bit weird. Then after this win behavior is triggered, I want to then cancel the scene, which takes us back to the first scene. So I want to go ahead and cancel scene 2. So I can duplicate this behavior for the red light. I'll do that pretty quickly. Now I've set up my two winner behaviors, green winner and red winner. Let's set up the tie behavior. It's also a started by action. Let's call this no winner. And I actually want both LEDs to turn on for maybe 7 seconds and then subsequently turn off. So nothing fancy there. You can add some sounds if you want, like green wins, red wins, or something like that to make it cool. So feel free to build away and make it just how you want it. So great. Now let's go back into the end game and actually tell COGS what to do in each case. So when the green score is greater than the red score, go ahead and trigger the green winner. When the red score is greater than the green score, go ahead and declare the red the winner. Declare no winner. It's looking pretty good. Oops, what do we have here? We have to also call the end game behavior within the gameplay behavior. Now it looks like our game is pretty solid, but remember we're not done yet. We need to actually go back to our first scene and set up our pre-game scene or our pre-game state. So let's do that next. Now for the pre-game scene, I actually want the players to press a button in order to show that they are ready to start the game. I'm thinking of player 1 ready, player 2 ready, fight kind of scenario. We could do this through a standard states match where we check for both button presses at the same time. But the problem is both buttons have to be pressed at the same time, which is not quite what I want. I want it to be possible to press each button independently, and once each button has been pressed at least once, the game actually starts. We can do this through the help of a variable, not a numerical variable this time, but an on-off variable. I've set up two on-off variables, which are red, ready, and green, ready. And we go back to our behaviors here, and we can set up a states match. It's a states match, so we want to check for when the green button is pressed. Go ahead, and I have an audio that comes with this button, so I want to play a whoosh audio. I couldn't find a green, ready audio track. So we actually want to play this whoosh sound. Let's play it until it's finished. And we want to then go on and update our green LED to on, and also our green ready on-off variable to on. So we'll do the same for red play. Perfect. So now our final behavior would actually check for these two conditions. If these two variables are on, then move on to the next scene. Let's call it ready. So we want to check for when the green ready is on, as well as the red ready is on. Go ahead and maybe have a delay of 1 second, just to let everything settle. And then we want to update the same variables to off, because when the next round starts, we want these to be in the off position. After which, go ahead and start scene 2. And go ahead and cancel or finish this scene. So we want to stop this scene because actually in COGS, 2 scenes can run concurrently. So if we have both scenes running, remember we have buttons, our buttons set up to do one thing in one scene and another thing in another scene. So we could actually have conflicting behaviors. So we want to end the pre-game scene, transition into the in-game scene, and when we're done with the in-game scene, we want to transition back to the pre-game scene. So I think everything looks pretty darn good so far. It might be a great time to actually test out our game. Let's find out. So I've actually tested it off camera and there is a little bit of a problem. So let's try to fix it. So here we told in the pre-game scene, we turned on the LEDs. So in the in-game scene, when we update our variables to 0, let's actually do that. So in the gameplay behavior, when we update our scores to 0, let's go ahead and actually turn off the LEDs. Great. So, and one cool little trick you can also implement so that you don't have to click on reset and restart, because I anticipate that this game is going to be played multiple times over and over. You might actually go into the show settings, which you can find right here, and go ahead and make sure that auto start and auto reset are on, both of them set to on. So we've made it to the end. Before I leave you, let's recap what we did in this build. So we set up 2 scenes, the pre-game and the in-game scene, to give our game proper game states. Inside the in-game state, we created 2 numerical variables, the green score and the red score, to keep track of each player's button presses. Inside the pre-game scene, we also set up 2 additional variables to signal the readiness of each player to enter into the in-game state. In the in-game state, we also went on to set up the press behavior, which increments the scores of each team with each button press. We also set up the end game behavior, which is a started by action. This is essentially a function that computes a condition that checks which team has more scores and triggers the right outcome. Finally, we set up the winner behavior, the 2 winner behaviors, as well as the tie behavior in the unlikely event that both teams have the same number of points. Now, if you take anything away from this video, let it be the usefulness of the started by action behavior. It gives us precise control over exactly when logic runs, rather than having it fire continuously while our game is running. Combined with the computed conditions, it let us compare the scores cleanly at exactly the right moment we wanted. Now, if you're feeling extra confident, try to set up the Media Master and figure out how to make Button Bash Battle better. See what I did there? Button Bash Battle better? Never mind. But for me, Joe, that's it for today. Until we meet again, build on.